Question 15 is a volume question involving algebra. The diagram shows a prism, and remember, a prism is a 3D shape with a uniform cross-section. So in this case, the cross-section is the H shape, and that runs all the way throughout the shape. So the diagram shows a prism. All measurements are in centimetres, and all corners are at right angles. The volume of the prism is V centimetres cubed. Find a formula for the volume. So they're not actually looking for an answer here. They're not looking for the fact that the volume equals 630. They just want to know a formula. So volume equals what with regards to X. So let's have a look. In order to find the volume of something, first thing I need to do is find the area and times it by the depth. So this here is the depth of my prism. I'm going to ignore that for now. I'll come to that later. I just want to find the area of this H shape first. Now I can't find the area of a H shape, so I'm going to have to split it into shapes that I recognise, and that is a rectangle, and a rectangle. Now, if I notice, the width of that rectangle is the same as the width of that rectangle, and the heights are the same also. So that means these two rectangles are going to have the same area. So the first thing I'm going to do is find the area of the tall skinny rectangles. And I'm going to find the area of one, and area, as we know, is base times height. Now the base is x minus 1, and remember we tuck it all together in a bracket, and the height is x plus 3. So I'm going to end up with x minus 1, x plus 3. When I expand that out, I get x squared plus 3x minus 1x minus 3. I then need to collect and simplify, so there's a positive 3x there. Take away 1x is going to leave me with positive 2x. I've not done anything with that x squared. I've not done anything with that negative 3. So that is the area of one of the rectangles. Now I know I've got two of those rectangles, so I'm going to go ahead and do that now. I'm going to find two lots of x squared plus 2x minus 3. Two lots of x squared is 2x squared. Two lots of 2x is 4x. Two lots of negative 3 is negative 6. So that's the area of both my rectangles, these ones. Now I need to find the area of this little rectangle here. And this is actually going to be slightly tricky, because whilst I've got the base, or the width, which is 2x, I do not have the height, so I need to work that out. Now, in order to find the height, I need to take the height of the whole thing, so that's x plus 3. I need to subtract that part, which is x, and that part, which is x. So, height of centre is going to be equal to my x plus 3 minus an x minus another x. So what I'm actually going to end up with is x take away x is 0 x's, take away another x is negative 1x, and that 3 I haven't touched, so I've got negative x add 3. Now it's not very convenient having a negative floating around at the front of an expression, so as long as the 3 is positive and the x is negative, I think it's friendlier to write that as 3 minus x because the 3 is still positive and the x is still negative. Now, the fact that I found the height of that rectangle means I can now go ahead and find the area of the shorter rectangle, and that's going to be the base, which is 2x. If you want to group it up into a bracket, you can, but it doesn't really matter. 2x, and then I've got 3 minus x, so 2x times by 3 is 6x. 2x times by negative x is negative 2x squared. So now I'm going to do it over here. I'm going to find my total area of the cross section. That's the H shape. In order to do that, I take the 2 rectangles, which I found to be 2x squared plus 4x minus 6. And I'm going to also introduce the area of the little square. So I'm going to add, because that's a positive 6x, I'm going to add 6x in there, and then I'm also going to add that negative 2x squared, so negative 2x squared. The fact that I'm saying add the negative comes down to the fact that you're adding them, but it's overall a negative operation. So here I've got 2x squared, take away 2x squared, which leaves me with no x squareds. Here I've got 4x and 6x, which is positive 10x. I've not done anything to that negative 6 yet. Now, don't be tempted to leave your question there, because that is not the answer. That's worth quite a few marks. However, that is just the area. Now, what I wanted to find was the volume. So in order to find the volume, I need to take my area, which is 10x minus 6, and I need to times it by the depth, which is x plus 3, that one there. And now I can expand my brackets out. It's a good job, I enjoy doing this. 10x times by x is 10x squared. 10x times by positive 3 is positive 30x. Negative 6 times x is negative 6x. Negative 6 times positive 3 is negative 18. Collect and simplify. So I've got my positive 30x. I've got my negative 6x. They go together to give me a positive 24x. I've not done anything to my 10x squared, and I've not done anything to my negative 18. So that's it. Volume equals 10x squared plus 24x minus 18. Okay, so now I have found the formula that v equals 10x squared plus 24x minus 18. I can have a look at where the marks are allocated for this. So I get a an answer mark for getting the correct answer. Now, I get a method mark if the examiner can see sight of you finding an expression for the missing side. So that gets me a method mark. My second method mark then is for having a correct expression for any one of the areas. So it could be for that area, or it could be for that area. Either way, I get 1 mark for finding the correct area. I get then the second method mark for finding a total cross section. So Oh well, that's my cross-section method mark then. Up here I suppose is my area marks. So there's the 4 marks. Answer mark, finding one of the areas correctly, finding one of the missing sides, and then showing that you're finding the total cross-section to multiply by the depth. Question 16 is quite a tricky one to explain, and I wish I'd practiced it before I'm doing it here, but I didn't. So let's go. A and D are 2 points on the circumference of a circle. A and D. A and B are 2 points on the circumference of a smaller circle. DB and AC are tangents to both circles. The fact that they've mentioned a tangent, I'm going to underline, because that makes me think straight away of circle theorems. E is the intersection, that means it crosses, of DB and AC. So yep, E does cross with those. E is the midpoint of AC. And they want us to prove that ABCD is a rectangle. So let's look at those points. A, B, C, D is a rectangle. Now, whilst this isn't going to count as proving it's a rectangle, I am just going to sketch a rectangle in, just to remind myself what I'm trying to prove here. So there's my rectangle. Okay, another thing that they've mentioned in there is that this is a point of intersection. So that's actually quite important. They've mentioned it. Now, when I read this, I said I thought of circle theorems as soon as I saw the word tangent. And that's because of the circle theorem rule that says a tangent to a circle that comes from the same point are always equal in length. So in that case, this here is a tangent to the large circle. That is also a tangent to the large circle. So that means that these lines are the same length. So I'm going to make that statement. I've noticed that the line AE is equal in length to the line DE. And the reason I know that is because tangents from the same point are equal lengths. Okay, so if that's an equal length because they're the tangent of that circle, then let's have a look at the tangents of this circle. Now the first tangent of the smaller circle is again AE. The other tangent is this line, EB. So knowing what I know about tangents from a point, I know that AE has also got to be equal to EB. So I'm going to say, under the same reason here, that AE is also equal to EB. So what I can see up there now is that AE is equal to DE, and AE is also equal to EB. So essentially what I'm saying is if that is equal and that is equal, then E is the midpoint of DB. So if E is the midpoint, I know that that length is twice of whatever. As I'm talking about midpoints, I was told in the question that point E is the midpoint between this line here of AC. So if E is the midpoint of that line, and E is the midpoint of this line, and these lengths are all the same, then what I end up with are diagonal lines to my rectangle that are of equal length and they bisect one another. Now, I'm going to write my reasons down first. I've just got ahead of myself. So the fact that I've noticed AE is equal to EC, which was in the question, because it said it's the midpoint. So AE is equal to EC. That must mean that AE is equal to EC, which is also equal to DE, which is also equal to EB. So I'm saying all of those lengths are equal. Now, because all of those lengths are equal, what I can clearly say is that the line DB is equal to the line AC. And if DB is equal to AC and they're diagonals that bisect one another, then that confirms that any quadrilateral is going to be a rectangle. So off the back of that statement, I can say that if diagonal lines bisect and are equal, we have a quadrilateral that is a rectangle. And that, I'm going to check with the mark scheme, should be my full mark answer. Alright, so the marks are allocated. You get your B1 mark for recognising the statement about the tangents, and it can be for saying AE is equal to DE, or it can be saying that AE is equal to EB. The fact that I've got both doesn't really mean anything. I get 1 mark for that aspect. Now I get a second mark then for recognising that if the tangents are equal to one another and the tangents are there and that's the midpoint, then all of these lengths are going to be equal. So I'm going to get my second mark for recognising that all these lines are equal. Now my third mark comes from recognising the fact that if they're all equal, then that must mean that the full diagonal lines are also equal. So I get my third mark for recognising that there. And then I get my final mark, which is a communication mark, for clearly communicating the fact that I know tangents are equal when they come from the same point, and I know that if I've got 2 diagonal lines that cross in a quadrilateral, that means that my quadrilateral will be a rectangle. So there are 4 marks of my proof question. You should always just give it a go.